In our last video, we discussed some of the early models of the atom. And the last one that we had was Ernest Rutherford's nuclear model, where he discovered the nucleus, which was positively charged, surrounded by small negatively charged electrons. Now, a colleague of Rutherford actually continued to study the nucleus. His name was Chadwick. Was able to determine a little bit more about the nucleus. He worked with Rutherford, and they discovered that there was a way to actually determine the number of protons in the nucleus. And the protons were the positively charged particle that made up the nucleus. Because Rutherford theorized that if electrons were negatively charged particles, protons, but there must be some other positively charged particle, and they decided to call it the proton, which means the first particle, because they were in the center. However, when he and Chadwick worked together, they determined that the number of protons and what they determined was the mass of the protons didn't quite add up. In other words, even if they counted all the protons, there still seemed to be some mass that was unaccounted for. So Chadwick eventually theorized that there must be a third particle that he called the neutron, because it had no charge. Okay, so the nucleus is made up of neutrons and protons. So our three subatomic particles are protons, electrons, and neutrons. Okay, the symbol for proton is P+, the symbol for electron is E-, and the symbol for neutron is N0. Now we talk about the electrical charge that they have. Protons, each proton carries 1 unit of positive charge, and each electron carries 1 unit of negative charge. And the neutrons, the word meaning neutral particle, have no charge, 0 charge. You will also need to note where they are found in the atom. So protons are in the nucleus, and so are neutrons. And electrons are outside the nucleus. Okay, we will spend a little bit more time later talking about exactly where those electrons are. Now, the last thing that you are required to know about the particles in general is how big are they compared to each other. That's called relative mass. How big something is compared to something else. Now, obviously, protons, neutrons, electrons are incredibly small. Okay, scientists have been able to determine the mass of them in grams. However, because they're so small, they decided to come up with a special unit just for subatomic particles. And that unit is called the atomic mass unit, or AMU for short. So this stands for atomic mass unit. Now initially, protons were thought to be exactly 1, and neutrons were thought to be the same size. So we refer to each of these as 1. The reality is that as our instruments got better and we had a little better information, we discovered that they didn't actually weigh the same. Initially, the masses were calculated to be the same. Okay. However, we found out later that neutrons are a little tiny bit larger than protons, and protons are a little tiny bit less than 1 AMU. But for our purposes, we can say they're about 1, and neutrons are about 1. Now, how big is an electron? Remember that Thomson said that electrons were incredibly small. Turns out that the mass of an electron is about 2,000 times smaller than either a proton or a neutron. Okay, so you would need 2,000 electrons to be the same mass as 1 proton. We don't have any element that has 2,000 electrons. So when we talk about how heavy elements are, okay, we're really just focused on how many neutrons and protons are in the nucleus, because the mass of electrons is what we call negligible. It really doesn't matter when we're talking about mass. Now, the next thing that we need to know is, okay, well, how do we know, or how many protons or neutrons are in any particular nucleus? Now, the number of protons is called the atomic number. Okay? And okay, the number is unique to a particular element. Okay? So because each element has only a certain number of protons, we can think of the atomic number as an identification number for an element. Now, how do you know the atomic number for a particular element? Well, if you look at the periodic table has some information in it. Okay? This is a very simplified periodic table, but this particular periodic table, okay, these numbers right here, whole numbers. Okay? If you look at your periodic table, you will notice that your periodic table also contains whole numbers. Okay? And you'll notice that they go in numerical order, starting with 1 on the left. Helium is 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, this is called the atomic number. Okay, so the number of protons is the atomic number, and every element has its own number of protons. We'll come back to that in just one second. Now, protons are positive. Okay. And electrons are negative. Okay. Atoms are neutral. So that means that in an atom, even though they're made out of positive and negative charges, they're neutral overall. It means the overall atom has no charge. So that has to mean the amount of plus positive charge has to equal the amount of negative charge. Or you have to have the number of protons has to equal the number of electrons. Okay, so if an atom has 13 protons, that means that its atomic number is 13. And if you go to the periodic table, that means it's aluminum, or aluminium, as the British say. So that means it has 13 electrons. Okay, so let's go back to our periodic table for a second. Okay. So, if I asked you which element on the periodic table has 20 protons, you would say, okay, 20 protons, that means the atomic number is 20. You go to the periodic table and say, that's element number 20, calcium. Now, since it has 20 protons, it means it also has 20 electrons. So if I asked you which element on the periodic table has 35 electrons, you'd say, 35 electrons means 35 protons. 35 protons means an atomic number of 35. And you come over here and you discover the atomic number 35 is bromine. So that's protons and electrons. That's pretty easy. What about the neutrons? Well, to talk about the neutrons, we need a second number. This is called the mass number. The mass number is the mass of the nucleus in atomic mass units, which means that it's the protons and the neutrons. Now, why do we not add the number of electrons in here? Because it takes 2,000 electrons to be the same as 1 proton or 1 neutron. So if I have the mass number, how do I find the number of neutrons? Well, I would have to take the mass number, and I'd have to subtract away the number of protons. And that would leave me with the number of neutrons. So anytime you see the word mass number, I want you to think protons plus neutrons, or P plus N. Now, on my example periodic table, there are no atomic masses listed on here. Now, in your periodic table, if you take a look at it, okay, you will see a number with a decimal. Now, here is the tricky part. That is not the mass number. You say, well, then what is it? It is something very close but different. It's called average atomic mass. Okay, this is a calculated value. Okay, in our next learning objective video, we will talk about how do you find average atomic mass and what does it mean and why is it different than the mass number. Okay, let's go back to some of our examples here really quickly. Okay, so you will be asked to, for example, okay, if you have an element potassium is K, okay, with a mass number of 40, you'll be asked how many protons, how many electrons, how many neutrons, and what's the atomic number. Well, it's potassium, so let's go to our periodic table and find potassium. Here's potassium. Okay, we look up right here, and here's the atomic number. The atomic number is 19. So I'm going to write that in. Atomic number 19. Now, atomic number of 19 means 19 protons. The protons and the electrons, you have to have the amount of same number of positive and negative charge. Also going to be 19. Well, how do I find the number of neutrons? Well, I'm going to go back here, and this is going to be 40 minus 19, which is 21. So the nucleus has 19 protons, 21 neutrons, for a total number of particles is 40. Okay, the mass number can also be thought of as the total number of particles in the nucleus. So this is 21. Okay, one more example. Okay. Let's take a look at an element with 7 electrons, and a mass number of 15. And again, I want protons, electrons, neutrons, atomic number, and this time I also want the name of the element. Alright, so you have to go through the thought process. 7 electrons. Electrons and protons, you have to have the same amount of negative and positive. So that means it's 7 protons. Okay, you already know it's 7 electrons. 7 protons means the atomic number is 7. The neutrons is going to be 15, the mass number, minus the protons. So it's going to be atomic number of 8. Excuse me, a neutron number of 8. Alright, so let's go to the periodic table and find atomic number 7. There it is. That is nitrogen. Okay, so that's what you're going to need to know. Good luck.